The sun's activity can trigger earthquakes, and now we know how. On a dynamic planet like Earth, it can be easy for drivers of change to go unnoticed, but scientists have now established and investigated an unexpected link between the sun and our home world. Sunspots, and therefore solar activity, cause seismic activity, according to the team led by computer scientist Matthäus Henrique Junqueira Saldana of the University of Tsukuba in Japan, and their new research reveals how. Solar heat drives atmospheric temperature changes, which in turn can affect things like rock properties and underground water movements, he said. Such fluctuations can make rocks more brittle and prone to fracturing, for example, and changes in rainfall and snowmelt can alter the pressure on tectonic plate boundaries. While these factors may not be the main drivers of earthquakes, they could still be playing a role that can help to predict seismic activity. There's a lot going on here on Earth. Our planet has a squishy interior covered by a crust that is divided into discrete sections and an active weather system. There are a lot of potential triggers for monumental shifts in the planet's crust that could result in an earthquake. We're not very good at predicting seismic activity. There are simply too many variables, and the process that leads up to a tremor or quake is long and complicated. However, knowing the triggers means we could better assess the probability of earthquake activity and keep a keener eye on potential early warning signs. Saldana and his colleagues, applied mathematician Yoshito Hirata of the University of Tsukuba, identified a correlation between sunspot activity and earthquake activity in a paper published in 2022, but it was not clear why. One hypothesis was that the heat might have something to do with it. Sunspot activity waxes and wanes with cycles of solar activity that have to do with the reversal of the sun's magnetic field. Solar maximum, the point at which this reversal takes place, is a time of rampant solar activity. And the increase in solar irradiation due to flares and other solar tantrums also creates a tiny increase in temperature, about 0.1 to 0.2 degrees Celsius. In follow-up research, Saldana, Hirata, and their colleagues investigated the potential link to temperature further. They added to their model including records of sunspot activity and temperature records of Earth's surface, conducting mathematical and computational modeling to see if they could establish a correlation. Their results showed that adding surface temperature to the mix improved the accuracy of their earthquake predictions, especially for shallow earthquakes originating in the planet's upper crust, rather than deeper mantle-driven rumbles. Now, since it's the layer of the planet most affected by atmospheric temperature and the water cycle, it makes sense that changes therein would affect the upper crust more strongly, the researchers say. And this finding highlights just how complicated our planet is, as well as its relationship to our life-giving star, but it also gives us one more tool to add to the growing kit of variables to factor into earthquake prediction models. It's an exciting direction, Saldana says, and we hope our study sheds some light on the bigger picture of what triggers earthquakes. And this was published in Chaos, an interdisciplinary journal of nonlinear science, and it's from Science Alert, Michelle Starr. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.